So today we will discuss or we will have hands-on on data entry in Excel, assessment of cosmetic and logical errors. We will discuss. After that, we will do about the introduction of SPSS, data entry in SPSS, cleaning of data in SPSS, coding, decoding of variable in SPSS. After that, there are descriptive analysis. Means descriptive means we will calculate mean, mode, median, interquartile range, minimum, maximum of. Okay, so this is called descriptive analysis, including normalcy check of quantitative data, that is a normal distribution. Okay, and for qualitative data we will do frequency and percentage distribution. And 1 minute, I want to, yes. And after that, we will do histogram, bar graph, box plot, and pie charts on Excel or on SPSS. Okay. So first of all, we will discuss about what do you mean by statistics. So as we know that it is the science of analyzing the data and representing the research finding. Okay. And it is a systematic play with data. So what we are doing with data systematically, it is statistics. Like for any game to play, we have to have a playground or platform. So similarly for statistics, we have various software to play with data. So these are called statistical software. So at least we should have thorough knowledge in at least one software. Okay, and SPSS is easy software, easy to learn software. So most of lot of researchers are using SPSS for their data analysis. So these are the software you can see in my left upper side, that is Excel, Microsoft Excel. So we can perform lot of statistics, or I think almost all statistics with Excel. Okay, there is a package is statistics. There is a data statistics. Okay, then this is SPSS number 2. You can see here this is SPSS logo. Okay, then GraphPad, Prisma. This is fourth number is MedCalc software. Then fifth is this is 13 version of that is Stata. Okay, then this is nowadays R is using, R Studio is using. This is a SAS, statistical analysis software or system. Okay, and nowadays it's like V is a Zamovi software. Zamovi software. It's a free. It's a similar to SPSS. We can do lot of like analysis with this Zamovi. It's a free of cost software. But when we talk about advanced statistics, then we use advanced software, PAD software, okay? And this is JASP software. It is based on SAS software, like many researchers are using. And there are many more other software, Statistica. That is like one more software, that is Statistica. So like many more. And nowadays, as Khurana sir told that we are using AI. So with the help of AI, we can do statistics, we can do our calculations. But please don't rely like blindly on these AIs, okay, tools. So for validity and reliability, we have to use these software. And when we talk about SPSS, so SPSS, GraphPad, Prism, MedCalc, Stata, R, SAS, Jamovi, and this JASP software, and Excel is also software. So these are paid software, you know very well about these. But we have Microsoft Excel in our laptop. We are getting when we are purchasing our laptop or system. We have Microsoft Excel in our. R is free software. Jamovi is free software, and JASP is also free software. So we can perform these statistics with these free of cost software. Okay. but R is like some more complicated. Okay, we need skilled to like learn R, SAS, and MedCalc, something Stata. Okay, but for this SPSS, it's a very user friendly, very easy software. Even in Excel, we have to have some knowledge about how to use Excel in statistics. Okay, so SPSS is very user friendly. I want to say SPSS is very user friendly. So if we do commands, we give commands, so our result will automatically calculated. So nowadays, SPSS is using by a lot of researchers. But I want to say we are using SPSS, but and I recommend it. Please enter your data entry in MS Excel sheet first, and after that, I recommend it that after entering data in Excel sheet, MS Excel, please export to or import to this SPSS software, because we know that SPSS software sometimes like we are like a lot of like researcher are using like pirated version and cracked version. Okay, so it is a pirated and cracked. So if we do data entry in this pirated or cracked version, so there is a chance of I think lost of the data. Okay, but Excel is like we have Excel in our software. So I recommend that please enter data in MS Excel first, then easily export these MS Excel into SPSS. It's very easy. Okay. So why? It's a user friendly, usability and accessibility. Like most of, I think I want to say that all of the like laptops or system having this Excel. Okay. So accessibility is 100%. Every computer, laptop, smartphone, tablet, etc. has this MS Excel. So it is recommended by the statistician. Please enter your data in MS Excel sheet. Once data are entered, they can be easily imported to any statistical software. Please remember this. If we enter our data in MS Excel first, we can easily import these like data into any statistical software. So all statistical software are compatible with MS Excel. So no need to worry. So just enter your data in MS Excel and then import these data into any statistical software. There is no problem. So outline of the Excel sheet, many researchers don't know like about these things. Okay, so what is like Excel spreadsheet having, that is columns, rows and cells where we have to enter data in column and how to enter data in rows, cells. So I will explain about these first. So this is like MS Excel. You can see here, and I think when you open MS Excel, it is looking like this on your system. So there you can see here columns are, you can see here. So these are the columns you can see. This is A column, B, C column, something like A, B, C, D. So vertical are columns. It's a very minute things. But when we enter data in MS Excel, so we are doing lot of mistakes. So it is very essential to first learn what is columns and what is rows and what are the cells. Then we can enter data easily, and how to enter, there are some rules I will explain. Okay, so these are the columns A, B, C, D, something like that. Okay, so then what do you mean by rows? You can see here, these are the verticals. So these are the columns. Okay. So when we talk about rows, so you can see here, these are the row 1. It's a horizontal. Okay. This is row 2, row 3, row 4, row 5, etc. You can see here. So these are the column. These are the rows in Excel sheet. And what do you mean by cells? So these are the cell you can see here. Yes. So it's a cell B1. Okay. Cell B2. You can see here. This is a column is B and row is 2. So it is called cell B2 or 2B, something like that. These are the cell. Okay, you can see here rectangle. These are the cells. So this is arrangement of like our MS Excel. We have to understand this first. Now there are 6 rules of thumb to enter data in Excel sheet. It is very essential to know these 6 rules of thumb how to enter data in Excel sheet. Around 80% of the researchers are making mistakes in data entry. Okay, so if they're in mistake in data entry, so it is not possible to do analysis with any other software. Okay, by SPSS, Stata, Medcalc, even R Studio. Okay, so these are the some basic principles you can say we have to remember while entering data into Excel sheet. So number one is variable name must be entered in the first row of Excel sheet. Please remember, variable name must be entered in the first row of Excel sheet. So you can see here, so all variable names should be or must be in first row of Excel sheet. And variables are serial number, name of the patient, age, gender, okay, date of admission, outcome mortality, hypertension, something. These are the variable name, okay, etc. So these must be entered in the first row of Excel sheet. Please remember this, okay? And number second rule, each observation must be entered in each cell. Okay. For example, these are the cell. So you can see here, for example, this in first row, there must be variable name. And from second row, our data must be, our observation must be entered from second row. Okay, there should be not any blank row. Okay, there should be not any blank row between row 1 and row 2. Okay, so here in first row there is our variable name, and in second row our observation or data entry should be from our this second row. Okay, these are the cells. So individual observations should be entered in each cell. For example, here age is 39, so it is entered in here in this cell 39. Okay, according to this, and we will do, then I'll explain you. Each variable must be entered in each column. So this is again same thing. So here these are the column, you can see here. So these are the column. So here in column A, and this is row 1, we have to enter variable name here. For example, age, AGE. Okay, we have to enter here. Then in second, here in second column, we have to enter here in first row, and this is a second, B is a second column. So here we have to enter sex or gender here, SEX, okay, or gender, GENDE or something like that. In third, we have to enter, for example, hypertension. So hypertension, yes or no. So hypertension we can enter full, otherwise we can enter initials, HTN. Okay, yes or no here. Okay, so this is meaning of this third rule. Okay, now please remember this rule, rule number 4. First column in spreadsheet must be serial number. Okay, why it is serial number in first column of Excel sheet? When we do analysis, so this first column, that serial number is very useful. Okay, so when we do analysis, then I will show you the benefit of this fourth rule. Okay, So where is first column? This is first column. You can see here. This is first column here. So it must be serial number. This is first column. A is first column, and in row 1 we have to enter variable name. So in first column we have to enter serial number SNO, something like that we have to enter, and from row 2 we have to enter 1 2 3 4, something like that. Okay, so please remember all these things. Now number 5, never merge any cells in spreadsheet, Excel sheet. Never merge. So if you merge, none of this software can perform statistics. So please never merge. If you are doing this mistake, so please be aware, never merge any cell in spreadsheet. Please remember. Number 6, okay, we know about this number 6. Space between words of any variable is treated as illegal character in statistical software like SPSS, Stata, MedCalc, etc. Okay, so we have to avoid this space. So, for example, if you want to separate words in variable, okay, if you want to separate words in variable, use underscore instead of giving space. So, what do you mean by, for example, variable name is history of present illness. So please write down as history underscore present underscore illness. So it is not treated as illegal character, and we can perform analysis in SPSS, Stata, Mail, etc. Okay. So please remember these 6 roles. Okay. So this is a entry. This is an example of entry, how to enter data in Excel. So you can see here in first column, you can see here, this is a first column, that is E. Okay. This is the first column. You can see here E. I want to take this printer. Okay. You can see here in A column, it is written down as a serial number. You can see here in first row, all the variable name is written. Okay, you can see here. Okay, in first row, there is a serial number. So please remember. Okay, so please remember, always keep serial number in first row. Okay, if you want to give in second row, no problem. If you want to give in end of the Excel sheet this serial number, it's okay, there is no problem. But please give serial number column. One column should be serial number in your Excel sheet. So it is, if it is a first column, it's very good, because we can say the number of which number of the patient has this entry. So we can say it's a 16 number, 17 number from starting, we can say. Then you can see here it's a patient name. So it's a patient underscore name. We can write down variable in capital letter, small letter, whatever we want, we can write down. But you can see here patient and name is two words. So there is a space between these two words. So space, there is should be not space between two words. So I have connected with this patient underscore. You can see here, I want to zoom it. Okay. So if there is a zoom, okay, 1 minute. You can see here patient underscore name. Okay. Then age, you can see here, please see this. This is a age. And in data entry, from second row, there is a data entry of age, number 1 patient, number 2 patient. And you can see here what we are making mistakes. We have written age, okay? And in second row, there is a 47. You can see here, this is a 47. So we just written 47 years, 58 years, YEARS, 34 years, YEARS, something like that. Please don't make any mistake to write down these years here. If you write down like unit of that particular variable, please write down in first row in variable column name. For example, age underscore in years. You can write down here. Okay, but in these cells, please no, please never write down units here. If you write down here in units in cells, so then none of the software can calculate and can perform statistics on this variable, that is a age. So please remember this. Okay, this is a group. You can see this is a group. So we have like researcher has given this coding 1 and 2. So please remember, always give coding 1 and 2. How to give this coding, I will explain you. And please remember, what is group 1 is experiment, group 2 is control, something like that. So we have to we have to write down what is group 1 and group 2 in coding sheet. So I will make you coding sheet here also. Then you can see here, these are the variable lesion, MLD, like short form, something like that, underscore mm means millimeter unit. So these are the entry of the data sheet. You can see here. Okay. Then these are the, so you have to remember this, how to enter data in. You can see here in all like variable, there is no any unit, something like that. Okay. So you can see here, it is a wider format. Here you can see here this arrow, orange color arrow. Okay, it is going into like right direction. So it is, if we enter data in this, it is called wider format. For example, like baseline data, after that 3 month follow-up data, after that 6 month follow-up data, after that 1 year follow-up data. So it is going to wider. Okay, it's called wider format data. Okay, and this is longer format data. If you are enter data in this way, you can see here left side there is a longer format down arrow. Okay, orange color down arrow, it is called longer format data. So we have to just remember, we should have knowledge about this. Then you can see this Microsoft Excel, and you can see, you can think about what are the, like when this Excel sheet like came to me. Okay, one like a researcher sent to me, okay, please do analysis of this Excel. So like I when I saw this, so I think I got like shocked that how can I do this analysis, because none of the software can do analysis with this Excel sheet. Okay, so you can see here, you have to remember 6 rules. Okay, how to enter data. So okay, when I see here in like column 1 must be serial number. Okay, column 1, that is a column, serial number, it's okay, serial number, but there is no, it's a space, you can see here there is no underscore. Okay, so we have to give underscore serial underscore no, and from second row we have to enter observations. But here you can see from fifth row, this is number 1 patient, number 2 patient, number 3 participant, number 4 participant, number 5 participant, but it's not from row 2. So it's a wrong entry. We cannot perform any analysis with this. Okay, you can see here. Then we like MRD number, age, age is okay, there is no problem. Name is okay, there is no problem. Diagnosis okay, it's okay. These are the, but when we are talking about this variable present history, and after that there is a weight, headache, blurring, so weight gain, headache, blurring, something like that, vomiting, yes and no. So they have entered data in the form of coding. 0 means no, 1 means yes. So if patient having headache, it is entered as 1. You can see here, number 2 patient. But if patient is having or participant is having headache, no, okay, no, this is like given as a coding 0. So number 1 is we have to enter data in coding format 0 and 1, something like that. Okay, rather than yes and no, because when we analyze these 0 and 1, it's very easy to do. Otherwise, lot of the software cannot perform analysis with the yes and no format. So we have to change. It is called coding and decoding, something like that. Okay. So you can see here this present history, this is variable name, and you can see here this cell 1, 2, 3, 4, 5, 6 cells have been merged. Okay, so I told you that none of these cells should be merged in Excel sheet or a data sheet. So this is number 2 mistake. You can see here. Then here also you can see here there is also and uh, there is, you can see past history, they have entered NAD means no. Okay, something like that. That is a, there is no past history of anything. Okay, so, but I told you that we have to enter data in coding format, 0 and 1, something like that. You can see here in GC and general condition of the, okay, here, okay, this is GC variable, and here they have written fair, poor, fair, something like that. So when we perform analysis like inferential statistics, for example, t-test, ANOVA test, something like that, we cannot perform on this variable. So we have to enter data like in coding. Fair is, poor is 1, fair is like 2, something like that. Okay. So we have to enter data according to this. Now, this is again, so these are minute mistakes we are doing when we are entering data. So number main thing is, you can see here in first row there must be variable name. So these are the variable name, something like that. Mode of like delivery, something, gestation age, baby weight, something. Okay, these are the UPGAR scoring, NICU admission, and from second row we have to enter data. Okay, so you can see here in because here it is entered in from fifth row, so it is a wrong format for like wrong entry of the data. But yeah, you can see here BP means blood pressure at the end of intervention. It is given as 134 by 100, 140 by 100, systolic and diastolic. Please never enter any like findings in the form of slash something like that. You have to enter systolic BP in the separate column and diastolic BP in separate column. Same as like SERFT, like serum electrolyte values, sodium, potassium, chloride, urea, creatinine. We have to enter, generally we are entering in slash, sodium, then slash, then potassium, then slash, something like that, okay, in one column. But please enter in 5 different separate columns, okay, sodium in one column, potassium in second column, then chloride in third column, something like that. Please remember this, okay? And we can see here in side effect, they have merged the side effect, so it is wrong entry. And then these are the headache, they have entered in like coding 0101, it's a very good thing. Okay, 0101, it's very good, but they have made some mistakes. Okay, so we have to understand these things. Now, so it is necessary to avoid data entry mistakes in data entry in MS Excel. So how to enter data, I have explained you, and then I will give you hands-on. So if we have data and we have knowledge about data, then we have to like enter data in correct way, then we can perform statistical analysis. We can do statistical analysis. So data entry, correct format of data entry is very essential in MS Excel or in any other software. So what is data? Okay, data. So we have to understand what is data. Okay, so anything in this universe and beyond this universe, okay, that is data. For example, what is time? Okay, how many participants have joined? Okay, and age of the participants, gender of the participants, how many male, how many female, all things are data. So anything in this universe and beyond this universe are data. Please remember this. Okay, mobile phone, that is data. Black mobile phone, that is data. Okay, And SPSS, like this is workshop is also data. SPSS workshop is also data. Anything is data. Height, weight, BMI, anything is data. And what is statistics? It is play with data. So if you play with your like interest, so that is statistics. Okay. And it is also understand the data, talk with data, listen to data, and play with data. So if we understand the data, and when we talk and listen this data and play with data, then we can perform statistics very easy. So there is no problem. Okay. So first we have to understand about data. So this is most important slide. Okay. So what interchangeably, sometimes we are using data name or sometimes we are saying that it is a variable. Okay. So data or variable. So basically data or variables are two types. Number one is quantitative, number one is qualitative. So please remember, okay? If there is a dependent and independent variable, so these are also coming in quantitative and qualitative category. So this is base of statistics, data or variable types. It is a quantitative data or qualitative data. Quantitative means numerical data. These are, for example, 120, 15.4, 26.3, etc. Numerical. And qualitative means that is, it gives a description of things like good, soft, bleak. Okay. So you can see here. Then quantitative data is further divided into two categories, that is a continuous data and discrete data. So what do you mean by continuous data? Please remember this, please understand this. In fractions or decimals we are presenting. Usually we measure these data. For example, 165.6 centimeter, that is a height something. Okay, so this is continuous data. We can give decimals. We can present in the form of fractions. For example, age, height, weight, BMI, systolic BP, diastolic BP, HB, electrolytes, exam scores, anxiety score, depression score, time, okay, distance. So we can present in these data, okay, in fractions. So these are called continuous data. And number two is discrete data. We cannot present in decimal or fractions. We have to give in full whole number. Usually we are counting it. So for example, number of family members. Okay. So if I ask any participant, oh, thank you. If I ask any participant how many family members you have, so you have to give one answer, 3, 4, 5, 6, 7, whatever. Always and always it comes in a whole number, full number. If suppose if there are three adult and two children, so we cannot give like answer the 3.2 something like that. We always say 5 members. So always it comes in full number. So it is called discrete data. Okay, usually count, for example, number of family members, pulse rate, number of chairs. You can see here, you can think about this, heart rate, and you in etc. You can add which type of data we can present in a discrete format. So if we cannot give decimal or fractions, we cannot present in the form of fractions, it is called discrete data, but it should be in numerical format. So please remember this, please understand this. Now comes to qualitative category. Okay, for example, male and female, religion, Hindu, Muslim, Sikh, Isai, color, white, black, red, behavior, personality, day, night, alive and dead, good and bad, present and absent, etc. So these are called qualitative data. So you have to remember this. Disease severity, mild, moderate, severe. So these are called qualitative data. Okay. So you have to understand this slide, okay, thoroughly. Then when you do analysis, it will be very easy for you. Okay. Now, and these are next is level of measurements. Please remember this number 2 slide, level of measurements. So in statistics, and when you open SPSS and any other software, so there is also level of measurement, something like that, nominal, ordinal, interval, ratio, something. So first we have to understand these level of measurements. Okay. So we have to think about number one is nominal. Nominal means names. So the variables are only named or attributes are only named. It is very weakest form of the level of measurement. That is a nominal. Okay. Number two is ordinal. Attributes or variable can be ordered. So for example, okay, please like listen it. For example, level of satisfaction. Okay. Highly satisfied, dissatisfied, okay, dissatisfied, highly dissatisfied, then satisfied, then highly satisfied. So there is some order. In disease of severity, there is a mild, moderate, and severe. It is order. So when we are giving order to any variable, so it is called ordinal variable. Okay. So what do you mean by nominal? We cannot give order to that variable. For example, gender. Gender means male and female. So to gender variable, we cannot give any order like females or males are higher than females. We cannot give order to this gender. Or for example, religion, Hindu, Muslim, Sikh, Isai. So all are equal in the form of religion. We cannot give order. If we want, even if we cannot give order, so it is called nominal. We cannot give order. Hindu is superior than Muslim. Yeah, Muslim is superior than Hindu. Sikh is superior than other religion. We cannot give. So these are called nominal variables. We cannot give order. For example, your name. Okay, name of the patient. So we cannot give like one name is, for example, X. So we cannot give X is superior than Y, X is superior than Z. We cannot say this. It is called nominal type of variable. But if we can give order, then it is called ordinal. So you have to think. You have to think about variable. Then you have to think, can we give it order or not? Then it comes into ordinal and nominal. Okay. Now interval. It is written here. Distance is meaningful. Okay, there is no problem. Please remember this. Interval, there are only few variable come into interval category, level of measurement. So just remember, for example, temperature in degree centigrade, okay, and temperature in Fahrenheit. These like temperature variable come into interval category. Okay, how I will discuss. Number two, IQ level. Number third, okay, number third is year, that is years 2001 2000, this is to 2026. This is variable is year variable is and comes into interval category. How I will explain you. Okay, now comes to ratio. First comes to ratio. So ratio means it has absolute zero. So what do you mean by it has absolute zero? And in interval, it does not have absolute zero. That is a difference between two things. Ratio level of measurement has absolute zero variable. Okay. And interval level of measurement does not have absolute zero. So what do you mean by, please listen carefully. For example, absolute zero means if we give that variable zero value, it means it is not existence. For example, zero height, it means no height, there is nothing. Okay, it is called absolute zero. For example, weight is 0 kg, it means there is no weight, it means it is absolute. Okay, distance, that is a zero. BP is a zero, systolic BP is zero, it means there is no zero, there is no existence of that. That is called absolute zero. But in case of interval, please remember, if I say temperature of my room is 0 degrees centigrade, it means there is a zero is a present, there is a temperature. So you have to think about this, the difference between ratio and interval. If I say the temperature of my room is 0 degree Fahrenheit, it means the temperature is existing. Okay. But if I say my room temperature is 0 Kelvin, okay, 0 Kelvin. This is a unit of temperature. So 0 Kelvin has absolute zero. If there is 0 Kelvin, there is no existence of this universe. So you have to remember interval and like degree centigrade and degree Fahrenheit. The 0 degree centigrade and 0 degree Fahrenheit, after 0, there is a existence of temperature. But when we talk about 0 Kelvin, so 0 Kelvin means this world is not existing. Okay, everything is destroyed. So that is like meaning of this absolute zero. 0 kg means there is no existence, there is no weight. Okay, 0 height, uh, 0 heart rate, 0 BP. So it is a difference between ratio and interval. You have to remember this. Okay. So it is called NOIR. N means nominal, ordinal, interval, and ratio. So please see this. Nominal means eye color. We can give name, okay? Eye color. Black, brown, something like that. Ordinal means level of satisfaction. Dissatisfied, highly dissatisfied, satisfied, highly satisfied. So we can give name even, and we can, this is a natural order. Okay. And in interval also, that is a temperature. We can give name also, that is a 31 degree centigrade, 32 degree, 37 degree. So we can give order. 31 is like 31 is like 31, and then 32, then 37. We can give order. But here, equal interval between variables. Okay, so there is a equal interval. Like for example, there we can like measure only interval, but we cannot get ratio. Okay, so in ratio, that is a height, we can give height name. Okay, there is no problem. There is a natural order, and main thing is it has a true zero value. Height zero means nothing. So we can get a ratio between two values. One person height is 6 meters, something like that, and second thing height is 12 meters. So we can say second is twice, okay, lengthy compared to one. But if one room temperature is 10 centigrade and second room temperature is 20 centigrade degree, okay, so we cannot say ki second room temperature is like double hot compared to room 1. Okay, room 1. We cannot, we can give, there is a difference. The difference of 10 degrees centigrade between room 1 and room 2. That is a 10 degree centigrade and 20 degree. The difference is 10 degree centigrade. But we cannot say it's a double. But when we talk about ratio, so if height is like 12 centimeter and second height is 6 centimeter, so we can get ratio. So one height is double of second object height. So this is a meaning of this nominal, ordinal, and interval ratio. And please remember in interval, temperature, because we are from health researcher. So number one is temperature. Number two is IQ level. Number third is year. So these three variable, temperature in centigrade and in degree Fahrenheit, these are in interval scale or level of measurement. Okay, these okay. But ratio, we can take any numerical value, quantitative variable, and ordinal and nominal we have to see, like severity of disease, mild, moderate, severe. That is, we can give natural order. So we have to remember this. So on the basis of why it is very important level of measurements. So for example, we can calculate type of the descriptive statistics. So these are the descriptive statistics: mode, count, frequency, okay, median, minimum, maximum, range, mean, variance, standard deviation. So you please remember this. If this is a nominal type of measurement, we can get only mode, counts, and frequency and percentage in the form of if we have nominal. But if we want to calculate median, minimum, maximum, range, mean, variance, standard deviation, these are not logical for this nominal type of. For example, gender. So we can calculate how many male, how many females. But if we are calculating median for gender, minimum, maximum for gender, range for gender, minimum, median, mean, and standard deviation for gender, so it's a illogical thing. Okay. Number two is ordinal. So if it's ordinal, for example, level of satisfaction, for example, disease severity. So we can calculate how many are like mild, moderate, and severe patients, how many are satisfied. So we can calculate mode, count, and frequency, but also we can calculate median, minimum, maximum, and range also. But it is coming in interval and ratio. You can see here for interval and ratio, we can calculate all these things. We can calculate mean, variance, and standard deviation. Okay. So if it is like a normal distribution, I will show you. So we can calculate mean and standard deviation. If it is not normally distributed, we can calculate median, minimum, maximum, and range. So how, okay, so you have to like remember and understand these slides. Then we can perform statistics very easy. Now move to SPSS. Okay. So I want to like highlight some. So it is like a statistical package for social science earlier, and now it's a statistical product and service solution. Okay, that is a SPSS. So these are, we have to thank these like guys, Nee, Bent, and Hull, who developed this SPSS and made our life very easy. Now come to normalcy check of quantitative data in SPSS. So first we will like complete this 2-3 slides theoretical, and then we move to how to enter data in Excel, SPSS, and perform these like descriptive statistics. Okay. So if our data is quantitative, so I told you basically data is two type: quantitative and qualitative. Qualitative is also called categorical data. Please remember, quantitative is also called numerical, and qualitative is also called categorical data. Okay. So category means male and female, two category. Okay. Mortality, yes. Mortality, no. That is a two category. It may be more than two, something like that. Okay. So normalcy check must be for quantitative data. If data is quantitative data, that variable is normally distributed, we can calculate mean and standard deviation and can perform parametric test. What are parametric test? I will like discuss tomorrow. And if this quantitative data, for example, age is quantitative data, it is not normally distributed or skewed, then we have to go for non-parametric test. And what are the non-parametric test? We will discuss in coming sessions. Okay. So please remember, normalcy test, there is a hypothesis. So please see this. Hypothesis is a statement of relationship between two or more variable. Null hypothesis, that is, there is no difference, there is no change, there is a similar findings. And research or alternate hypothesis, we know very well about. there is a significant difference, there is a significant change. So that is our research or alternate hypothesis. Null hypothesis of normalcy test. There are normalcy test, different type of normalcy test. So null hypothesis of normalcy test states that the sample is normally distributed against the alternative hypothesis, and that is it is not normally distributed. So if null hypothesis is true, it means our sample is normally distributed. Sample means that is that variable. And if alternative hypothesis is true, it means it is not normally distributed. Sorry. So please remember this. If the normalcy test, there are most familiar tests are Kolmogorov-Smirnov and Shapiro-Wilk test. These two tests we are using to check normalcy of quantitative data. If the normalcy test p-value is less than the predefined significance level, usually we are taking p-value less than 0.05. So we can reject the null hypothesis. So if we are getting p-value less than 0.05 on Kolmogorov-Smirnov or Shapiro-Wilk test, so we can reject the null hypothesis and we can say the data are not normally distributed. Quantitative data are not normally distributed. And if p-value is greater than 0.05, we cannot reject the null hypothesis and we can conclude that the data or sample is normally distributed. So please remember this. But we have to remember this also, not that small deviation from normality can produce a statistically significant p-value when sample size is more than 100. That is, a sample size is large. And conversely, it can be impossible to detect non-normality with a small sample size. That is a sample size less than 10, something like that. So if sample size is large enough, so if there is a small deviation, we can get p-value significant, that is a less than 0.05. And if samples is less than 10, so it is very difficult to get p-value less than 0.05. So in this condition, we should always examine the normal plot, that is a histogram and QQ plot, and use our judgment rather than relying solely on these hypothesis tests, solely on the Kolmogorov-Smirnov or Shapiro-Wilk test. So we have to perform first test, and after that we have to use our judgment using these histogram, QQ plot, and our judgment to whether this particular quantitative variable is normally distributed or not normally distributed. Okay. So this is normal histogram. You can see this is a frequency and this is a hemoglobin level gram per deciliter. So normally we are getting histogram of quantitative data. Please never do histogram for categorical or qualitative data. Please remember this. Never get histogram for this. Only for quantitative data or numerical data, we should go for like histogram. So it is normally histogram with curve. Okay, so it is histogram with curve line. That is it is a norm. It is a bell-shaped, symmetrical. You can see here. So it is normally distributed. Okay, but what happened? You can see here we have to see skewness or tail of this normally histogram. So in approximately normal distribution, the skewness value, please remember this, the skewness value should be plus minus 2, within plus minus 2. Okay. And for type of skewness, we have to look at tail. So for you can see here, if tail is in our left side, it is called left skewed. In between that is a approximately normal distribution. And if tail is on our right side, it is called right skewed. So when we perform this analysis on SPSS, then we will see, and I will ask you, okay, what is the distribution of this, okay, skewness. And for approximately normally distribution, the skewness value must be plus minus 2, okay. And sometimes we are using kurtosis also, so it should be plus minus 2, okay. So it is called approximately normal distribution. Skewness value and kurtosis value should be plus minus 2. And we have to see normal probability, that is a QQ plot. It is called quantile plot. And it shows the distribution of the data against the expected normal distribution. Okay. For normally distributed data, observation should lie approximately on a straight line. I will show you. And if data is not normal, the point form a curve that deviates markedly from a straight line, and possible outlier are point at the end of the line. So you can see here it is QQ plot, and this is for age variable. You can see here, and all these observation, this is QQ line, okay, quantile line, and all observations are close to this line, so it is called normally distributed. If there is like deviation, so these end point, you can see here, this is end point and this is end point, it is markedly deviated, okay. So this is called not normally distributed. So it is on the like close to this line, it means this age variable is normally distributed. So we have to use our judgment also by seeing this QQ plot. So if you have any query, you can ask me like in chats. And now we have start data entry in MS Excel, okay? Then transport the Excel data in SPSS, and then start how to enter data in SPSS, okay? So we have to move for like to our hands-on practice, okay? So just right click, then this is, you can see here, this is a Microsoft Excel. Please open this Microsoft Excel, okay? So I will open it. You can see here. But for data entry, we have our data collection performer, okay? There should be a data tool. So I want to show you data tool, okay? This is data tool. Here, this is tool. So there is one study is going on. So this is tool. So first we have to make our variable. You can see here in this is tool, and generally we are having this in the form of Google form or in this, okay. So if we have Google form data entry, so it's directly in Excel sheet, then we can use that Excel sheet and we can decoding that we can use. So it's a like, first of all, this is a socio-demographic profile of the participant. You can see here, and this is a code number, and this is a name of the participant, age, CR number, address, phone number, alternate phone number, gender. You can see here, marital status, one male, two female, three other. Marital status, you can see this is a general form of data collection, okay. And one is single, two is married, three widowed, four divorced, education qualification. You can see here. And these are the 1, 2, 3, 4, 5, 6, 7, 8. These are the coding already given to in this tool. Okay. This is the occupation. You can see here this. Okay. Type of family, one nuclear, two joint, number of family member, residence, total income, dietary preference, family history of medical illness, okay, migraine, hypertension, diabetes, something like that. Family history of surgical procedure, you can see here. This is a clinical profile of the participant. This is an anthropometric measurement, height, weight, BMI, height in centimeter, BMI, weight in kg, BMI in this, okay. These are the vital signs. You can see here, diagnosis, indication, okay. So this is a data tool, okay. So we have to enter this data tool into first MS Excel. Okay. So please see here. Okay, code number. So we have to enter code number means serial number. So what we have to enter here in serial number. So as I told you, in first row of in first row, okay, we have to enter variable name, and in first column we have to enter serial number. So what I have to do, I have to enter S underscore NO. Okay, it's very simple. Number two, then where is my data tool? This is my data tool. Name of the participant. So I can enter name underscore participant. So you can see here name underscore participant. Okay. You can enter in like in small letter also. There is no problem. Mix of small and capital letters. It's okay. But you have to enter data according to this. Name of participant, name underscore participant. Number third, we have to see. Number third is age in years. So what I have to do? Here I have to write down age underscore EYRS, age in years. Okay. Now this is CR number. Okay, if you want to keep the CR number for medical record, you can enter. There is no problem. So it's a CR number. CR. This is a, sorry. This is a number. Okay. So in each variable, name should be in each column. You can see here, and name of the variable must be in a first row. Okay. Now next is address. If you want to enter address, you can enter. There is no problem because we can get how many are from Haryana, Punjab, and Chandigarh, Jammu and Kashmir. We can get it. Okay. So I can address. Okay. Now this is phone number. Must enter phone number. It is very essential. So this is phone number. I can copy paste also. There is no problem. Phone number or mobile number. Then alternate. Okay, there is no. Then gender. Okay, gender. I can skip this alternate phone number because in phone number I can enter phone number 1, then comma, phone number 2, alternate phone number I can enter in this column. Then you can see here, when I like bring my cursor here in this line, and then it automatically, here this is in white color, white plus, okay, white plus, you can see here. But when I bring my cursor here, it automatically changed into black plus. And then I can drag it, I can increase this size of the column, decrease the size of the column. Okay, you can try this. Now gender, so I can enter gender also. Yes, then click here. Okay, if suppose I forgot this enter gender, and directly if I enter this marital status, for example, so I can copy paste it, select it, then Control C, and then paste it here. Okay, this is marital status. Then please remember, there should be no space between any two words of the variable marital space status. So what I have to do, I have to remove this space, backspace, then shift and underscore marital status. I forgot. Okay, I did not enter variable name gender, but I want to enter. I can enter here gender, but according to this tool, gender came first to like this marital status. So I want to enter according to this situation. So what I have to do, please click your cursor here. You can see here down arrow. Please click, then click right, then click insert. So it will automatically insert a column between phone number and marital status. You can see. Then enter gender. If there is a spelling mistake, no problem. Gender. Okay. So these are the variable name I have entered according to this. Then education qualification I can enter. No problem. You can see here education qualification, and the rule is same. I have to, there is no space, underscore. So I'm entering according to this. Okay, now one, two variable I just enter here. Okay, suppose I have entered all these things. Then now type of family. Okay, type of family. If I want to enter, Control C, then click here and then click type of family. So I can just write down here. This is, sorry, this is, I can wide this, I can increase this length of this column, and then type underscore family, sorry, underscore. Well, okay, it's very good. If you want to write down type of underscore family, it's okay, there is no problem. Okay, now suppose, okay, family history of medical illness. Okay, so how to enter this? Control C, then click Alt and Tab. It will automatically give our Excel sheet. Alt and Tab. Alt and Tab. Okay, then click this here. So it's coming like very lengthy. So what I have to do, I have to drag from here to here. Then I can do family history of medical illness. If I want to keep this, so there is no problem. Enter. Off I can remove and medical illness. Okay. So this is entry, how to enter. But suppose you can see here, when I like enter variable from here to here, you can see here, these variable here, the name of the patient is, you can disappearing, you can see here. Okay, you can see here like this, it's appearing name of the patient here. Okay, and suppose if entry is on 50 in 50, like 50 variable, row in here, so there is no any variable name is disappearing, you can see here. Okay, so if I want to enter here in this arrow, so I don't know in B what is it, in C what is it, in D what is it, I don't know here. Okay, what is variable of this, what is variable of this. So for this, what I have to do, please see this, I have to click this age, below this age. Okay, and then click this view. Okay, below this age, please click first below this age, then click view, and then click freeze panel. Okay, what I have to do, I have to click this below this age, in front of name of the participant, below this age. Okay, then click view, here home, insert, page layout, formula, data, review and view. Then click this freeze pans. Then click freeze pan and click this freeze pans. When I click this freeze pan, and when if I want to enter data in 50th row, then this variable name is visible now. You can see here. If I want to enter data here, so it is visible. I easily know which column is for which variable. It's visible. If I want to enter here, so I can see here this family history of patient number 57, or if I want to enter data here, family history of this. So this is called freeze pans. It is very essential to enter data, and it is make our life very easy. Okay, now I have entered. So first I want to enter data in serial number 1. Okay, so this is a serial number 1, serial number, code number or serial number 2, serial number 3. According to this, I can enter data 4. Please bring down arrow. You can see here 5, and then click down arrow. It comes to here. Then click 6. Then click down arrow. Then 7, something like that. Okay, name of the participant, whatever the name of the participant, we have to see our data collection performer, then we can like fill. So for example, it is A, it is B, it is whatever data. Okay, so I can enter data, there is no problem. Name of the, then for age, So what the age of the first patient? It is, for example, 32. So just enter only 32. 32 years, please never enter. Okay. Then 45. Number two is 45. Number third is like 54. So we can enter data according to this. Okay. Now serial number, we can enter serial number. Then address, we can enter address. Phone number, we can enter phone number. There is no problem. But in gender, please see this gender. We can enter gender by two ways. Number one way, male and female. Okay. So this here, please see here, this is male. Number one patient is male, so I have entered male. Number two is female, so I have entered female. Number third is again female, so I can enter female. Number fourth is male, so I can enter male. I think there is no any problem. I can enter data according to this. There is no problem in data entry. It's very good. But when we perform statistical analysis test, for example, T test, ANOVA test, okay, and any other test, then when we enter data according to this male, MALE, FEMALE, according to this, then we cannot apply T test on gender. We cannot apply like other test, Mann-Whitney test on this gender. So for this, for that purpose, we have to give coding. We have to give numerical coding to male and female. Okay. So there are different ways. For example, I can make my coding here. Please see this in bracket. In bracket, I can make code male is equal to 1 and female is equal to 2. I can make coding according to this. And then I can enter data male is equal to 1 and female is equal to 2 like this. Please see this. So I know what is male 1 and what is 2. But when I enter this according to this, you can see here this. So this void the rule number like rule numbers that is 6. Last rule. There should be no any space between these. Okay. So what I can do this, please remember, I can do this. There is no should be any space. So I can write down according to this. So when you play with these like entry, you will remember, okay, this is right entry. Okay. So I can do this. I can do data entry. Male gender underscore male underscore 1 underscore female underscore 2. So male is 1, female is 2. But this is very lengthy variable name. Okay. If I make this like for gender, then please see this for this sorry, for this education, I have to enter these 1 is equal to like professional degree underscore 1, graduate underscore 2, diploma underscore 3, high school underscore 4. So it would be very lengthy variable name. Okay. So it may be problematic. So to avoid this situation, what we should do, you can see here in Excel sheet, this is our sheet. You in like left side below this there is a sheet 1. You can see here my cursor sheet 1. Okay. But we can click here in plus, there is a plus new sheet. So please enter new sheet here. Okay. This is a new sheet. I can make this coding sheet and I can write down here male is equal to 1 and female is equal to 2 like this. And this is for gender. So I can write down here gender male is equal to 1, female is equal to 2. For remember, so what is male, what is female in Excel sheet. Okay. So please make one coding sheet in sheet 2, sheet 3, whatever. And in sheet 1, just enter this data entry according to this. You can see here. So what is 1 and what is 2? Sometimes we forget. So just click this coding sheet, sheet 2, and you can see here gender 1 is male, 2 is female. According to this, we have to like do data entry for marital status also. For example, one I have given code married for 1, 2. Here you can see here code single 1, married 2, 3 widow, 4 divorced. So I can give code in Excel sheet here, Excel sheet here, and then I can just like entry data according to, for example, 1, 1, 2, 3, something like that. So 1 is single, 2 is married, 3 is divorced, something like that. Similarly for education qualification, okay. Similarly for type of family, family, medical history, you can see here it's a medical history. Where is medical? Yeah, this is medical history 16 number, you can see here. Okay, so if migraine, hypertension, diabetes, please see this. So this is a family history of medical illness. So one patient may have migraine also, hypertension also, diabetes also, okay, like multiple condition. So in this condition, how can we enter data? So please see this here. So this is a medical history of illness, okay. Then here what I have to write down in this here I can write down number 1 is, what is number 1? Number 1 is migraine. So I can write down migraine. Migraine. Okay. What is number 2? Number 2 is, for example, hypertension. What is number 3? HTN. I can write down full hypertension or I can give initials. Number 3 is diabetes mellitus, something like that. Okay. So if patient is having migraine, it means yes. Not having, it means no or absent. So for yes patient, we can give 1, and for no patient, we can give 0. So 1, 0, 1, 0, something like that. We can enter data. For hypertensions also, we can give according to this. But carefully see your tool. For diabetes, we also give can like similar. And in data Excel sheet, I can write down migraine here. 1 is equal, yes is equal to 1, no is equal to 0. Please never give, please remember, never give no to 2. 1 is equal to yes, no is equal to 2. Please never. Always give 0 to no. Absent, 0 to absent. Present to 1, yes to 1. So these are the minute things we have to remember. Okay. So according to this, we can do data entry. Okay. So we can do, and we can do one by one for all these variable. For example, here, if I want to calculate this, want to enter this height, weight, and BMI. So I can enter data according to this. And you can see here, this family history of medical illness, it will be blank. No need to do anything because all these things will come in these columns. You can see here. Okay. So if I want to like remove this, I can remove. If I want to like keep it, I can keep this variable family history of medical illness. Okay. Now, number 3rd is here, last one, that is our height. So I can enter height in centimeter. Okay. Then I can enter weight. So I can enter. If there is a mistake in spelling, no problem. Weight and kg. And if I enter data in BMI, so BMI, here I want to write down kg meter square. You can see here. Okay. And then I have to write down, I have to fill these values. For example, height is 134 centimeter for this patient. This patient height is 135.5 centimeter. 145.6 centimeter, something like that. 145 centimeter. So these are the for weight and for BMI. I can fill all these according to these patients' tool. Okay. So this is entry of data in Excel sheet, how to enter. Please remember if there is any systolic or diastolic, if I want to enter, so please never enter this is a BP. Please never enter according to this 124 by 76. Please never enter according to this. None of the software can analyze this BP, mean BP, median, interquartile range, standard deviation. None of the variable software, okay, on this universe. Okay, so for this, what we have to do? We have to enter systolic BP separate and diastolic BP separate. Please see this. So it is a 124 by 76, and please remove this. So these are the minute things we have to remember. This patient is 134 and 70, 87, something like that. Okay. So we have to enter data according, never give and never merge any cell. Please remember, never merge. So by entering these data one by one, please save this, and please after entering 1 and 2 patient entry, you have to send email to you yourself, your friend, your guide and co-guide, because it is a laptop, it is a machine. Right now it's working. After time, due to any unfortunately, it's not working. So for safe side, please always email to you, your friend, your guide and co-guide this data entry. Okay. So you have to see which variables are quantitative variable, which variables are categorical variable by seeing this Excel sheet. Okay, by seeing this Excel sheet. So if I want to ask age, age in the years, which type of variable? It is a quantitative type or it is a categorical or qualitative type. Please reply in this chat box. I want to see. Please reply in the chat box. Okay, quantitative. So very good, quantitative, very good, very good. Okay, very good. So if have like if you think that this age is categorical variable, so it's not good. And Kiran Joshi, okay, continuous variable, very good. In quantitative, it is a type of continuous variable. Okay, yes. Quantity, it's not a quantitative discrete, it's a continuous variable because we can give decimals also. Generally, we are presenting in the like whole number, but we can give decimals also in age. Okay. Like for example, one patient age is 20 years and 6 months. So we can give 20.5. But generally, we are not doing this. But we can give decimal. So it is a quantitative and continuous type of. Okay. So very good. Thank you. So it's a two phone number data in one cell because we cannot analyze this phone number. It's a just for remember. We cannot analyze this phone number. So we can like give. Okay. Sir, what will happen if we give code number 2? Okay, if we give code number 2, sometimes what happen if we are calculating scores in the form of, okay? If we are calculating scores. So for example, for example, if there is a score, knowledge score. So if knowledge is having for like 10 questions having, okay. And if you are giving correct answer 1 or incorrect or you are not there is no knowledge of, so we are giving yes and no format, something like checklist, observation checklist. If they are performing step, it is yes, not performing if you are giving 2 number, okay. So when we add this total practice score, then if the participant is not performing, is like getting higher marks. If you are giving like 2 as a no. Okay, so I think you are uh, got my point. How to enter liquid data, like often, sometimes. So you can give according to, like often is like 5, sometimes is 4, always is something you can give according to. There is no problem. Okay, no problem. I will tell you. So, okay, so first we will complete this, then I will handle these query. There is no problem. So please tell me, gender. Gender is which type of data? Variable, gender. Please tell me marital status, education qualification. So what you have to think when you see variable, you have to think which type of variable, qualitative and quantitative. If qualitative, so it's like categorical, and if quantitative, what is it's a continuous variable, or it's a discrete variable. We have to think. For example, number of family member, which type of data? So you have to think this. Qualitative, categorical. Okay, very good. So if there is a two category, male and female, so it is called binary categorical, or no? Binary data, binary categorical data. Okay, for example, yes and no, hypertension, yes and no. So it is called binary, qualitative, categorical data. Very good. So this entry of this, we have to enter this. Now I move to, like, for SPSS. Okay, so it is also very important. So there is, I think, SPSS here. I have SPSS. I'm going to open this SPSS. So please open your SPSS, and you can do hands-on on SPSS. So it will take time. SPSS, when we open, it will may take some time to open. Be patient. So if you know, and if you aware, and if you have knowledge about the type of data, it is qualitative and categorical, and I think most of the, like, participants have correctly answered this. So it's a very good thing that you are getting knowledge about base of the statistics. So it's opening IBM SPSS statistics version 25. So many participants are facing downloading and installing this software. So I request them, please, like, you can try for trial version of 14 days. Okay. So this is SPSS sheet. You can see here. So it is similar to Excel sheet. Okay. And in SPSS Excel sheet, here you can see, one minute. What is it? You can see here. Oh, what is it? I'm not getting. Oh, so okay. So you can first see this. These are the cell. You can see these are the 1, 2, 3, 4. These are the row number here. These are the VAR, VAR. These are the column. And in Excel sheet, there is a B, C, D. And here, this is a VAR, VAR and variable name here. Okay. Here there are two sheets. Okay. You can see here left side down, there is a data view. You can see here. Okay. My cursor. So this is a data view. And here this is variable. You can see here. Click this variable view. Left side down side. You can see. When I click this, this is a variable view. This is variable view: name, type, width, decimal, label, values, missing column, align, measure, row. So this is coming in variable view. We will do one by one. Okay. So if okay, first I will enter data in Excel SPSS sheet. We can enter data directly into SPSS. No need to enter data in Excel sheet. Okay. And if we have entered data in Excel sheet, we can directly import this data into SPSS. So I will, like, if I don't have time today, I can explain you tomorrow, no problem. But we have to learn step by step, okay? So here, please remember, if I want to enter data, okay, if I want to enter data in SPSS, so I cannot directly enter data variable name, first variable name. I cannot enter here variable name. If I click here, it automatically, you can see here, goes to in variable view. Please see this data view. If I want to enter variable in variable view here, variable. So when I click this, it automatically like goes to in variable view. So it means if I want to give variable name here, then I have to enter in variable view. So click on variable view and then click in first. This is first name of the variable. So I told you in first column, these are the column here. These are the column 1, 2, 3. These are the column. Okay. These are the column. In data view, these are the rows. Please remember this. Okay. So in variable view, 1, 2, 3, 4, these are the column. So this is a number 1 column. And if I want to enter number 1 column, so I have to enter serial number. I told you. So I want to enter serial number. So suppose SERIAL serial, and then I want to give space. Okay, then I want to enter NO serial number according to this. Okay, number two, in number 2 column here, I want to enter name of the patient. So when I click this, my cursor, when I click this serial number automatically, variable name contains an illegal character. Why? Because this has a space, serial space number. So as I told you that if there is a space between two words of the variable, it is treated as a illegal character. So what I have to do, I have to click OK. Then again, I have to enter serial number without any space underscore and O, serial number. You can see here. And please see this. This is serial number, serial underscore and O number. And now I have to enter patient name here in 2 column. When I click here, please see this type, width, decimal, label, values, missing. All these things automatically highlighted. So please click this. You will see here. Please see the magic. Changes here. This one. Okay. And please see in data view also. Please see in data view also. This is serial number. You can see here. Okay. Then, so I told you that in first column, in first column, there must be a serial number variable name. Okay. Now go to variable view. Then I have to enter name of the patient. So I can enter patient PT. Okay. PT underscore name also. This is the patient name. I can enter. Then click third number. Please see the changes in front of this PT underscore name. Okay, just observe changes. Number 2, now age. So I want to enter age underscore YRS underscore years. Okay, then please see the changes. Now gender, GENDER, gender. Okay, please see changes. Please see. Okay, now systolic BP, SBP. Okay, this is a systolic BP, then diastolic DBP. These are the variable. Okay, then height, I can give only height, HT underscore centimeter. HT means height. Now weight, I can enter weight.
ऑटो हो जाता है गूगल
Okay,
में चेक करते मुझे
pardon. So this is weight in kg. So these are the, and then I can write down BMI. Okay. So BMI, these are the variable. You can see here in data view. Okay, so these variable name came in this here. Now I want to enter this data. Okay, so suppose in that column the tool is like same, that is our tool I have like used earlier in Excel sheet. So in serial number 1, so I have to give 1. Okay, please see this. I click 1 here. Then name of the patient, please see this. I have clicked this one. So you can see here 1 is highlighted here. If it is not highlighted 2. So when I click here 2, so you can see here it is highlighted, 2 is also highlighted according to this. Please see this. If I want to enter name of the patient here, for example, Mohan, okay? Mohan, Mohan. Number 1 patient is Mohan and Lal, Lal. I can give space here. In data entry, I can give, but I cannot give space in variable name, Mohan Lal. Please see this. Number 2 is Roma. Number 2 patient is Roma. When I click this here in 2, you can see here my cursor, then this Mohan Lal is automatically disappear. So what happened with this? Okay, I will again enter Mohan Lal. So it's automatically disappear without any like dialogues or error or message automatically. So what happened here? Please see this. Please see this. Go to variable view. And this is patient name is we have to see patient name is in a type of the variable is numerical. Numerical means quantitative. So patient name is not a numerical or quantity type of. It is qualitative or categorical. So what we have to do, in front of patient name there is a numerical. You can see here this cell. Then click this cell. You will get this. 3 icon you are getting. 1, 2, 3. Please see this. Patient name, patient underscore name in variable view, numerical, and in front of this 3 icon you are getting this. Please click this 3 dot. Okay, please click this 3 dot. You will get this this dialog box, that is a variable type. Okay, so in variable type it is not a numerical because patient name is qualitative variable. Okay, nominal type of variable. So please select this string. Please select this string. I think one is like drawing pattern. Okay, so please click this string. Please remember this, not numerical. Please click this string type of and then click OK, because patient name or participant name is not numerical type. It's a string means qualitative. In SPSS, string means qualitative. Then click OK. Now it is automatically changed. It is changed into string. Okay. Now in data view, now enter and you can see here the symbol of this. This symbol is a scale symbol. You can see serial number, age, gender, SBP, DPP, height. But it is automatically changed. It is called string type of alphabetically. Okay. So please click here Mohan Lal. Mohan Lal. So now if I'm typing lal, it's not coming. Okay, why? Because I have given only in variable view the width I have given only 8. Okay, so if I increase this width, click here, and if I increase this width, like click this arrow, or I can enter 20, I can enter here in width, then this width increase to 20. Then I can enter this Mohan Lal. You can see here. So for this long name, I have to go to variable view. then I have to increase this width. So when I click this here, it is coming like this. And upper arrow, I have to increase, and down arrow, I can decrease this width. Okay. Now, data view. Okay. Number two is Srikant, something like that. Okay. Srikant. So these are the variable name of the patient. I can now enter. Now age. So it says, for example, 34, I can enter 40, 54, something like that. I can enter 66, I can enter 32, 55. So I can enter these age. In gender, I can enter either male or female, or I can give 1 and 2. Okay. So in gender, here, if I enter male and female, okay, for example, MALE. So what happened when I want this patient is also, Srikant is also male. So I click here and I want to enter male here. It's automatically disappear. Why it's disappearing? Because it is a scale type of, numerical type of variable. So if I want to enter male and female, then I have to go to variable view. Then in front of gender, in type of variable, I have to click here, then it is highlighted. Then click this three arrow, three dots you can see. Then I have to change this from numerical to string. But I told you, okay, leave it. But I told you in gender, I can give coding 1 and 2. So 1 is for male, 2 is for female. So I can give coding. So I just enter 1 male. Srikant is also male. This is female. This is female. This is male. I can enter data according to 1, 1, 2, 2, and 1. Now for systolic BP, I will take only 5 minutes more. Okay. Now, systolic BP, I know very well what I have to enter. It is 122, 124, 134. I can enter data according to this. On this, then diastolic BP, I can enter.
ज्यादा नमक
I can enter for height, weight, and BMI. For example, for height, it is around 134.5. So it is coming according to this. Okay. 145.6, it is coming to this. Okay. You can see here. So I can enter data according to this one by one. Okay. I can enter data. Now I want to analyze this data. Okay. Suppose I want to calculate mean, median, interquartile range, or normally distribution of this. Normally distribution is must be only for quantitative data, not for categorical data. Please remember this. If you are like assessing normally, the variable is whether normally distributed or not normally distributed, it is only for quantitative or numerical data, not for categorical data. So here, this age is numerical data, gender is categorical data, systolic BP is numerical data, height is numerical data, DBP, diastolic BP is numerical data, weight is numerical data, BMI is numerical data. For these numerical variable, I can check normally distribution. But for categorical data, please never do this. For qualitative data, please never do this. Okay. So for normally distribution data, what we have to do? First, we have to assess normally distribution. So for this, I want to enter some more age. Okay. So 45, 34. Randomly, I am entering data to show how to see this normally distribution. Okay. So I can enter all these 30, 40, 50. Okay. Around 20 patients. Okay. You can see here it's up to 20. It means 20% I have entered data in age. Now please see, I'm going to assess normally distribution, mean, mode, median, and for gender, I can assess for frequency and percentage. So I can enter data for this gender also. So I will take only 2-3 minutes more. So for age, please see this. I think I can do. Okay, I cannot do. For this age, I want to assess normalcy. So what I have to do? Please see this. There is one button analysis. One by one, I will explain you these buttons. Okay. So this is analysis is most famous button and most usable button. You will use like frequently this analysis button. So this is analyze and then click this descriptive. Analyze. This dialog box will open. Okay, I will repeat this. Click this analyze. Then descriptive statistics. In descriptive statistics, please go to explore for normalcy check. Okay, analyze. Again, analyze. Descriptive. And in descriptive, there is a explore button over there. In descriptive, then explore. Okay, then click this explore. This dialog box will come. This is okay. If you have like different versions in make or in any other version, I have 25, so you may have some different dialog box, but basic thing, this explore dialog box will open. Now what I have to do, I want to check normalcy of this age variable. So please click you right left side. This is a age variable. Please click this age variable and then click. We have to bring this age variable into dependent list. Okay. So click this age variable. Select this age variable by clicking this, and then this is horizontal arrow. You can see. Okay, this is horizontal arrow in front of this dependent list. Then click this. You can see here this age variable came from left side to independent list. Okay, now then click this plot. Right side there is a statistics, plot, options and bootstrap. Okay, so please click this plots. Please click this. When you click this plot, this dialog box will come. You can increase or decrease dialog box by clicking you drawing this. Okay, then click this normality test plots with the test. This is here. You can see here in statistics plot option. Please click this plots. Then this dialog box will open. Then click this normalcy test with plot and then click this histogram in descriptive histogram. Then click this stem and leaf. No need to this. And then click this box plot. We can do box plot also. There is no problem. Histogram we can do and normalcy test with the plot with test. Then click continue. Okay. Click continue. Then click this option. No need to do anything for this. Okay, right now no need to do anything. Then in statistics, no need to do anything. On it, this is a descriptive. It's a default option, so no need to do anything. Then click continue. Okay, bootstrap, no need to do anything. Just click OK. So here what we have done in plots, we have checked this histogram. We have unchecked this stem and leaf. We have clicked this normality plot with test. Okay, it is default. Then continue. In statistics, it is also default. No need to do. Click continue. In option, it is also default. Not need to do. Continue. Then click OK. When I click this OK, the results is coming. So you can see here these results. Mean, okay, 95% confidence interval of mean. And then you can see here skewness and kurtosis value. This is statistics. Okay, you can see here statistics. So in statistics, you can see here skewness and kurtosis. You can see here median, this is 44.00. Standard deviation is 15.89. Always take two decimal. This is a mean is 46.05. Everything we are getting. This is a range. This is an interquartile range. This is a skewness. Please see this skewness and kurtosis. Skewness is 0.343 and kurtosis is minus 0.854. So what I told you, skewness and kurtosis value is between plus minus 2. So it's a normally distribution. So skewness value is 0.343, kurtosis is minus 0.854. It is between 2 to minus 2 to plus 2. So according to skewness and kurtosis, my age variable is normally distributed. And if it is coming close to 0, it means it is like approximately highly normally distributed. Okay. Now see this. Now see this Kolmogorov-Smirnov test values and Shapiro-Wilk test values. So if Kolmogorov-Smirnov, you can see it's a statistics, degree of freedom, and SIG. Okay. So SIG, it is a p value. SIG means significance. This is p value. In Shapiro-Wilk test, it is statistics means value of Shapiro-Wilk. Degree of freedom is 20 and SIG means that is a significance. So in both tests, you can see the p-value is greater than 0.05. In Kolmogorov-Smirnov, it is 0.106. In Shapiro-Wilk test, it is 0.315. So in both tests, it is coming greater than 0.05. I recommend Shapiro-Wilk test. So please see p-value of Shapiro-Wilk test. So it in this case, it is coming 0.315. It is more than 0.05. It means we cannot reject null hypothesis and we have to interpret age is a normally distributed variable. By seeing this Shapiro-Wilk p-value, age is normally distributed. We have to. If it is normally distributed, that time I can go for, then I can go for mean and standard deviation. I can take mean and standard deviation from here. Mean 46.05 and standard deviation 15.89. Okay. So I can take. If I want to take median, this is median is 44.00. Range is 23 to 78. Minimum and maximum, it is range 23 to 78. Okay. So by using this, and this is a skewness and kurtosis, also these two skewness and kurtosis indicating age variable is normally distributed. Test of normalcy, that is a Shapiro-Wilk test, is also indicating p-value is greater than 0.05. It means it is normally distributed. And I want to see, this is histogram, but its curve is not coming here. I will show you how to get it. And this is QQ plot. So QQ plot, you can see here, all the dots or majority of the dots are near to this QQ line, quantile line. It means it is normally distributed. And if I see this is a box plot, and in box plot this dark line in box, this is box, and these are the whisker. Okay, below and this above, these two are whiskers. So a door in between this box, inside this box, this is a dark line in middle, it is median. And here in lower side, it is like first quartile of the box, and upper side of the box, it is a third quartile of the box. I will explain you in like coming sessions all these things again, so you will get majority of this. Okay. And last thing, if I want to get like histogram of this with curve, so what I have to do, please go to analyze. Okay, please go to analyze, then go to descriptive statistics and click this frequency. Okay, analyze, descriptive and frequency. Please click this. You will get this dialog box. So for this what? I want to calculate age variable. So please click this age variable and bring this age variable into variable box using this horizontal arrow. So click this age variable from left to right. Okay, it came here. Okay, then click this statistics. Right side there is a statistics chart. Okay, most two button. So click this statistics. Please see this. Then this age variable is a quantity type of variable. It is a normally distributed variable. So for normally distributed variable, I can calculate mean. So in central tendency, in this dialog box, you can see here frequency statistics. You can see here mean. You can see here median. Just click. Okay. Quartile in percentile value, these are the quartile, first quartile and uh, second quartile and third quartile. Then click standard deviation in dispersion, then mean, then maximum, then this is skewness and kurtosis. You can, if you want to calculate, because we have already calculated, you can click. Okay. So mean, median, quartile, standard deviation, minimum, maximum, skewness and kurtosis, then click continue. And in chart, please click chart. Below this statistics, there is a chart button. Click this and there is a histogram chart. Okay. There is a histogram. Please see this. This is a histogram. Click this and here click show normal curve on histogram. Please click this, check this. Okay, box. And then click continue. And here is also there is a display frequency table. Okay, please leave it. Then click OK. So this is my last click. So you can see here in frequency, there is valid, yani valid, there is no missing, there is a 20 case, mean is 46.05 years, median is this, standard deviation is this, skewness and kurtosis, this because we have done already, and this is minimum and maximum we have done. But please see this here in percentile, 25 in first quartile, 50th is that is a second quartile, it is median also. So second quartile percentile, 50th is a second quartile, it is median. So 50th is 44.00 years. So you can see here median also, it is also 44.00. And 75th percentile is a third quartile, this is a 56.00. So median is 44 and interquartile range. It is called interquartile range. That is a first quartile to third quartile. 34 to 56. It is called interquartile range. Okay. Now this is a frequency table. Generally for quantitative variable, we are not using this frequency table. Okay. But this is a histogram you can see here. So it is like coming approximately normally distributed. You can see here. But if I want to interpret it, you can see here the tail is on right side, some right side. Tail is right side. Okay. So it is right sided skewness, but only some skewness. But when I see skewness and kurtosis, okay, so it is coming under normal distribution category, plus minus 2. Okay. So this is about how to calculate frequency, box plot, histogram, and how to calculate descriptive statistics. So thank you very much, and I'm really very sorry because we have done up to 8:20. But thank you very much. You are with me after this 8:15. Thank you very much. So if you and
Thank,
how
thank
to
you very
save
much,
this,
sir.
how to save this, I will explain tomorrow. Okay, no problem. How to save this result in Word file, I will explain you tomorrow. Okay. Yes, ma'am.
Thank
Sorry.
you very much for your valuable session, sir. I hope it was really useful for all the participants. And
So
you
if
have
you have
answered
any,
majority of
if,
queries also side by side. So that was, I
yeah,
think, useful for all of them. So
yes, yes.
participants, because you have many other days to stay with Dr. Ashok, and he will be telling you many amazing things further about SPSS. So stay in touch, and if you still have any queries, he is always available in WhatsApp chat box also. So you can put your queries over there. He can assist you throughout this workshop duration. And for now, we'll just wind up here, and definitely we'll meet again tomorrow sharp at 6. Before I close, I would like to thank our technical team for coordinating in all the events as well as throughout the session, staying tentative and making this all event possible. So thank you very much, Ratan sir, for your consistent support to all of us.
So
Uh,
if you have any query, you can like type in WhatsApp group. I will give like answer of all these queries and how to save this SPSS and how to import these result into Word file. So I will explain you tomorrow. Okay, it's easy things. So thank you very much, ma'am, and thank you all participants who have joined still 8:20. Okay, thank you.
Thank you very much, everyone.